welcome to this class. In this class, I'm going to introduce you to the concept of mole. So we are looking at the meaning of mole and Avogadro's number. You've probably heard about dozen, which is used by every person, including the market women. They talk about dozen of orange, dozen of eggs, dozen of biro, dozen of book, dozen of this, and dozen of that. For chemists, what replaces dozen for chemists is what we call mole. So when chemists want to measure things, they don't talk about dozens of it. They talk about moles of the substance. What is the mole of sodium present in this? What is the mole of water molecule present in this? What is the mole of CO2 present in this? What is the mole of this? What is the mole of that? So mole is for chemists. Other people talk about dozen. And just like dozen is defined as 12 particles of something, for chemists, a mole is the amount of substance that contains 6.02 10 by 10 raised to the power 23 particles of a substance. Dozen talks about 12 items, while mole talks about 6.02 10 by 10 raised to the power 23 items or particles of a particular substance. This 6.02 10 by 10 raised to the power 23 is what we call Avogadro's number. It was Avogadro that first gave us the idea of that number. So we call it Avogadro's number. Okay, so I said that a mole is amount of substance that contains 6.02 10 by 10 raised to the power 23 particles of the substance So particle means that it may be ions, it may be atoms, it may be molecules, or any form that the substance may exist. And I say that Avogadro's number is equal to 6.02 10 by 10 raised to the power 23. So we can also define a mole as the amount of substance that contains Avogadro's number, because Avogadro's number is equal to 6.02 10 by 10 raised to the power 23. Let's solve some examples. Okay, before we solve example, let's get this idea that having defined a mole as the amount of substance that contains 6.02 10 by 10 raised to the power 23 particles of a substance, it means that a mole of oxygen molecule contains 6.02 10 by 10 raised to the power 23. A mole of any substance, no matter what the substance is, must contain 6.02 10 by 10 raised to the power 23 particles of the substance. A mole of hydrogen atoms contains 6.02 times by 10 raised to the power 23 hydrogen atoms. A mole of chlorine ion contains 6.02 times by 10 raised to the power 23 chlorine ions. So we say a mole of hydrogen molecule contains 6.02 times by 10 raised to the power 23 molecules. A mole of hydrogen molecule, yes. Hydrogen molecule. So whenever you hear a mole, the first thing that will come to your mind is that constant, that number 6.02 times by 10 raised to the power 23. You should never forget it as a chemistry student. So our example 1. If somebody asks us to calculate how many moles of sodium atom is found in 1.05 times by 10 raised to the power 23 atoms of sodium. How do we calculate this? Looking at the equation, we are given the number of particles of the sodium atom. So what we are looking for is the mole. So when it comes to this, it's either we are looking for the mole or we are looking for the number of particles. Here we are given the number of particles and we are asked to find the number of mole. So the solution the first thing is that you have to remember that 1 mole of anything contains 6.02 times by 10 raised to the power 23 particles of the substance. Therefore, 1 mole of sodium atom contains 6.02 times by 10 raised to the power 23. Therefore, if we are looking for this, which is contained, we can say, if we are placing the number here, say we are given the number of particles as 1.05 times by 10 raised to the power 23, and then we are looking for the mole. Let's call it X. We don't know the number of moles that is contained in this, so we do our cross multiplication, this going to this and this coming to this, and so we have X times by 6.02 times by 10 raised to the power 23 is equal to 1 times by 1.05 times by 10 raised to power 23. This means that x, okay, our x is equal to 1.05, or our x is 1 times by 1.05 times by 10 raised to power 23 over 6.02 times by 10 raised to power 23. So what we are going to have is that the number of mole is equal to, our number of mole is equal to 0.2 moles approximately, 0.2 moles approximately. Okay, so this is the answer. Example 2. Example 2. How many moles of carbon carbon 4 oxide contains 3.04 times by 10 raised to power times by 10 raised to power 22 times by 10 raised to power 22. Here again we are given the number of particles and we are asked to look for the mole. So the solution again is for us to remember that 1 mole always contains 6.02 times by 10 raised to power 23, no matter what the substance is. Therefore, we take the number of mole given to us and put it where it's supposed to be. 3.04 times by 10 raised to power 22, 3.04 times by 10 raised to power 22. Then under the mole, we are looking for the mole. We don't know it, so we do our cross multiplication again. This going to this and this going to this, and so we have x times 6.02 times by 10 raised to power 23 is equal to 1 times 3.04 times by 10 raised to power 22, 1 times 3.04 times by 10 raised to power 22, and this is equal to, if we do our cross multiplication, we have that x is equal to 3.04 times by 10 raised to power 22 over 6.02 times by 10 raised to power 23, and so we have that our x is equal to 5.0 times by 10 raised to power minus 2 moles. this is the number of moles that this substance contains. Example 3. Example 3. What is the number of moles? The number of moles, or rather the number of ions, the number of ions present in zero point 0.5 moles of chlorine ion. What is the number of ions present in 0.5 moles of chlorine ion? Here we are given the number of moles and we are looking for the number of particles. Solution. Once again, we have to recall that 1 mole of any substance contains 6.02 10 by 10 raised to power 23, and therefore we are given the number of mole as 0.5. So we put the 0.5 under the mole. 0.5 is equal to, under the Avogadro's number, we are not giving it, we are looking for it, so we can call it x, and then we do our cross multiplication again, and this going to this and this coming to this, and so we have 0.5 times by 6.02 times by 10 raised to power 23 is equal to 1 times x, is equal to 1 times x. So what this means is that x is equal to 0.5 times by 10 raised to power times by 0.5 times by 6.02 times by 10 raised to power 23, and then this is equal to x is now equal to 3.01 times by 10 raised to power 23 particles of the chlorine ions. So this is the answer for this.